Slope. Slope is a ratio. It compares the change in the y-axis to the change in the x-axis. Simply put, it looks like a fraction. The top number, the numerator, is how far up or down you travel from one point to the next on that line, and the second value is going to represent the run, how far left or right you need to move on that line. If you have to move up, it's a positive value on top, and then your numerator would be negative if you count down. And likewise to a number line above a whiteboard in a classroom, if you head to the right on a number line, it represents positive, but if we move left, it would be negative. So let's explore this concept. Given this line that we have graphed onto the grid here with 2 points, always start from the lower point. Now that first word that we talked about, that rise, right? That rise. Well, how far up do we jump to get from the lower dot to the upper dot? 1, 2, 3, 4, 5. Because we jumped up 5, it's positive. Now we're going to place this over the run, right? How far left or right we move. From this point, we have to say how many do we jump to the right? 1, 2, 3. And because we move 3 to the right, it's positive 3. So the slope here, as a ratio, comparing rise to run, would be 5/3. Another example, we have 2 more points that we have placed on this line. Starting from our lower point here, let's count up to represent the rise. 1, 2, 3. Now we are at the same elevation as the other dot. So our rise is 3. And it's going to be 3 over what? Well, how many do we jump to the left? Because we're going left this time, we know our denominator is going to be a negative. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be a negative 8. Because we move left 8. The slope of this line is going to be negative 3/8. Your turn. Here's one for you to try. And let's see how you did. 1, 2, 3, 4, 5, 6, 7. And then our run, 2. Did you get 7/2? 7 over 2? One more. Alright, so let's count up. 1, 2, 3, 4, 5. So we count up 5. And then we count to the left. 1, 2, 3. So our slope, hopefully you got 5 over negative 3. Negative 5/3. Now this is for slope lines positive and negative, where we have clear jumps up and then we have clear jumps left and right. However, what if it's a flat line? Or what if, horizontally or even vertically? What about those circumstances? Well, those have very unique slopes to them. If we have a horizontal slope, you can see if we have a horizontal slope in our top example, there is no slope. Imagine slope like skiing. If you have skis on your feet, or if you're a snowboarder, you have a snowboard strapped to your feet. If you're standing on flat ground, there's zero slope. You're not going anywhere. Little different than undefined slope. Well, hopefully if you have skis on your feet or a snowboard, you're not faced with this either. A vertical line straight up and down. That's what we would call undefined slope.